Welcome back. We are looking at section 5.5, the substitution rule. We looked at some problems and solved them using substitution. And now let's look at some more. So next example number 5 is integrate sine square theta cosine theta d theta. Note here, I have changed the variable. Instead of x, I'm using theta, but we have to make sure that over here we have d theta, because that's what the that is the variable with respect to which we are integrating. So now this again, the first thing you have to do is compare with your table of integrals. If it doesn't fit there, then we have to think about manipulating it, doing something else. So what can we do? Well, there could be several things we can do, but not that all of them will be helpful. There could be more than one way to look at things, but not necessarily everything will be helpful. Now, if you recall, we have an identity sine square theta plus cosine square theta is equal to 1. So I have this sine square theta. I could write it as sine square theta equal to 1 minus cosine theta. That comes to mind, right? But will that be helpful? That is the question we need to ask. Will this be helpful? If I change this sine square to 1 minus cosine square? Actually not, right? It won't be helpful. Why? Because then our integral will become integral 1 minus cosine square theta times cosine theta d theta, and then which will become integral of cosine theta d theta minus integral of cosine square theta d theta. So it's more complicated because we don't see a derivative here or here. So this is not what we will do. Okay, we will not do this. Instead, we are going to look at, we have two functions being multiplied here. A trig function, one is sine square, and then the other is the cosine function. So we have to try to see one of them can be u. Again, which one should be u? I think someone said write this as sine of theta whole square. Very good. You can write it sine of theta whole square times cosine of theta d theta. So do you see something inside? Yes, that is your u. So u is equal to sine of theta. So du cosine theta d theta. Coming here, this becomes integral u square into cosine of theta. Okay, I have to get my d theta from here. So I get times du over cosine theta. Now cosine theta and cosine theta go away, cancel out, and we are left with integral u square du. So can you see how we have to get rid of our initial variable? We have u square du. Now, do we have to use u as our substitution? No, not really. For example, in this problem, the variable used is theta. So you could have used x as your x is equal to sine theta and do the rest of the problem. But be careful about this variables. Okay. So now what is the integral? It will be u to the third over 3 plus c. And now we plug back. So u was sine theta. So I get sine cube theta over 3 plus c. So that will be the answer to this problem. I hope you guys got it. Okay, looking at the next one, if you recall, when I showed you if we change sine square theta to 1 minus cosine square theta, and then we distributed, we saw an expression like this over here, the cosine cube x. How would we do that? Can anyone think? I hope someone got this, that we can always write it as cosine square x cosine x. Cosine square x times cosine x. Okay, maybe let me put them in parentheses so that there is no confusion. We can get a cosine square x times cosine x, that is cosine cube x. And what do we do now? We got the idea from the previous problem number 5, that if we have a single sine or cosine, then that kind of helps us with the derivative thing. So if the u I have to take is the quantity whose derivative is present, and u has most often or usually u is inside a function. So again, writing this cosine square x as cosine of x whole squared times cosine x. Well, okay, will this help? Let's see. Will this help? I mean, like if we take this as the u, then its derivative is not present. So this is the derivative of what? Cosine x is the derivative of sine x. So it means if I could get sine inside here, then that will be fine, right? That will be nice. So can we do that? Can we get sine? Yes. Why or how? Well, the Pythagorean identity. So you can write the cosine square x as 1 minus sine square x, and then multiply by cosine x dx. We don't even need substitution here. So this is going to, well, I take my words back. Okay, let me come here. So this is going to be sometimes you can use arrows or equal to signs here. So this will give you integral of cosine x minus, now I'm going to separate the integrals. It will be easier that way. Cosine x dx minus integral of sine square x times cosine x dx. Oh, this should be okay, but here you need to use substitution. Let's not put a let's put a t. So I will take t to be equal to sine of x, then dt will be equal to cosine of x dx. So dx will be equal to dt over cosine of t. Sorry, cosine of x u over du over cosine t. or is it x? Yeah, see, that's the confusion. Okay, let's go back u, because we are so used to using u. U equal to sine of theta, then du equals cosine of theta d theta. So the d theta will be equal to du over cosine of theta. We come here, first integral, I will just leave it as it is. I mean, I can evaluate it here, but let's just leave it as it is, and then we do this, both of them together. So now the sine square, we can use a substitution here. Now if you want to use the substitution, you cannot use u in the same substitution. Okay, we didn't use the substitution before, right? So this is what we are getting. D theta is du over cosine theta. So apply that over here. So we have integral of cosine x. Let me just take the antiderivative. So the derivative of cosine is negative sine, the antiderivative is sine. So we get sine x minus integral u square cosine x times dt over cosine x, which is equal to cosine x cancels out, and we are left with du u squared du. So that our integral becomes sine of x minus u cube over 3 plus c. And what do we do now? Just plug back in for u. So I'll let you guys do that. Okay, so what is the final answer? We have the final answer will be sine x minus sine cube x over 3 plus c. Okay, so one more problem. So here we have integral t square times square root of t plus 1 dt. Now this is kind of strange again, something we have not seen before. So if I had just the square root of x plus 1, then how would we do that? I mean t square root of t plus 1 dt. No idea. Okay, so here, so we could have used u to be 2t plus 1, and then we can find du. So du would be 2 dt, and then go from there. But here, although there is a t square outside, the only way I can pick my u is to pick the radicand, the expression which is under the radical sign. Under the square root sign in this case, we have to take that as our u. So we say let u equals t plus 1. Then du will be equal to just dt. So we just have to separate and write it like dt. So now when I plug back, so I will get integral for this quantity square root of t plus 1, this becomes square root of u du. But what happens here? What about x square? How do we figure out x square? So for that, I will look at my expression here. So t plus 1 is equal to u. So t will be equal to u minus 1. So t square will be equal to u minus 1 whole square. So using this idea, we can replace the t square by this quantity. Okay, so we have t square is u minus 1 whole square, so which will give us u square minus 2u plus 1 and then multiply by square root of u or u to the 1/2 power. Du. Now this became much simpler. We multiply by u to the 1/2 with each term, each of these terms, 3 terms. First term becomes 5/2 u to the 5, integral of u to the 5/2 minus 2 times integral of, I can take this out, or we could, the other thing we could do is just keep it like this. So integral u square u to the 5/2 minus 2 times u to the 3/2 plus u to the 1/2 du. Now when I anti-differentiate, I get u to the 7/2 over 7/2 minus 2 times u to the 5/2 over 5/2 plus u to the 3/2 divided by 3/2 plus a c. Simplify, it looks like 2 over 7. U can be replaced by the expression. So 2 over 7 times x plus 1 raised to the power 7/2 minus 2 into so u to the 3/2. 2 over 7, now it will be 2 over 5. Negative 2, we have negative 2 times x, that's okay. First I have to put the power. 2 over 5. 2 over 5 is coming from here. 2 was already there. Negative 2. So times 2 over 5 raised to x plus 1 raised to 5 halves plus 2 over 3 x plus 1 raised to 3 halves plus c. Now I need to simplify this further. So the final answer will be 2 over 7 x plus 1 whole to the 7 over 2 minus 4 over 5 x plus 1 raised to 5 halves plus 2 over 3 x plus 1 raised to 3 halves and the plus c. Well, a lot of algebra involved in here. Also, this can be simplified more actually, but I think you guys will get mad at me because that will be a kind of a lot more algebra. So I think if you get up till here, it should be okay. Okay, one more example. So here we are given this expression. So note here now, we have something at the bottom. In most of the previous problems, we didn't have much in the bottom. Most of the terms were on the top. So how do I do this? So again, you see, I have no idea what to pick you or what these things are. But what is our tip to pick u? The tip is u should be inside some function, inside quantity, and also u should not use derivative should be there. Well, derivative sometimes we can see it, sometimes we cannot. Okay, so just for the just try it. Just let's say let u equals the expression under the square root, which means 2x squared minus 8x plus 1. So du will be equal to 4x square, 4x sorry, minus 8. 4x minus 8. And then I have dx. I will keep this in parentheses now. So the dx will be equal to du over 4x minus 8. Now notice here I can pull out the 4 and I'm left with x minus 2. So see something, can you see? Some like good feeling that, oh, x minus 2 and 2 minus x, they are similar. Yes, they are opposite of each other. So actually this will work. We come here, integral 2 minus x divided by square root of u, and over here du over 4 into x minus 2. So how would I do that now? I'm going to move this a little further so that we have space. So now this can be simplified as, now if you kind of can see that they are opposites of each other, then what happens when you divide opposites? You get -1, right? So when they cancel out x minus 2 and 2 minus x, you can say -1 is left here. Or you can pull out the negative sign from one of them and you'll see that you get the other expression. So I can I can put 1 over 4 is outside here, integral. So I'm going to pull out the negative sign from the top. So I'll get negative of x minus 2. And then divided by square root of u. And then du over x minus 2. Can you see now x minus 2 and x minus 2 cancel out? And the negative sign is there. So we end up getting negative 1 over 4 integral. Now we have du 1 over square root of u, which I can write as u to the 1/2, times du. How do we solve this one? So negative 1 over 4, I can write it as u to the negative 1/2 du. Apply the power rule. Negative 1 over 4. So u raised to the power negative 1/2 plus 1 is 1/2 over 1/2 plus c, which will give you answer negative 1 over 4. Okay, this 2 is going to play a role. So 2 will go up. So you get 2 times u raised to 1/2 plus c. We are still not done. Now we have to substitute back the u, and then we can simplify the expression. So this 2 will cancel 4 and we'll end with negative 2 at the bottom, or negative 1 over 2. So now I'm going to write the final answer, which is negative 1/2 times square root of 2x squared minus 8x plus 1 plus c. So this is how you do these problems by substitution. Okay, in the next video I will show you how to plug in the limits, how to solve definite integrals using substitution.